Morning, guys. You can hear me now?
Yeah, Rich.
Okay, good, good. Well, it's good to have you here. I'm at the S2S Technology Center, and I'm in the S2S Crime Lab, or as Paul said, it's a forensics laboratory. And we've been tasked by the FBI, Federal Bureau of Investigation, to help them solve a major crime here. What's happened is, and I'll read what the FBI has given us, but this is a case of forgery. Someone has been stealing large sums of money from a major corporation. So, FBI's told us that the corporate treasurer has found out over several months that several checks in the amounts of $1,000 or more have been written and signed with the treasurer's name, although the treasurer claims he wasn't the one to write them. So while the signature on the check looked like it was from the corporate treasurer, we figure it must be a forgery. Somebody had been practicing signing the treasurer's name and is now using it to put it on corporate checks. Now, the other important part is they've made the check payable to cash instead of making it payable to a business or to an individual. So with a check that says cash, they can walk into a bank and they can get money for the check without even having to tell them who they are, just the fact that they've got a signed check with them. So there would be no record of who cashed the check or who received the money. And I'm going to show you here an example of one of those checks. So you can see this one's in the amount of $1,000. It's been made out to cash, and you can see the treasurer's signature down there on the bottom. So the FBI thinks that this is what they call an inside job, meaning it was done by someone who is within the corporation. They actually think it's from the same office where the treasurer has his desk and where all the blank checks are kept. So while the FBI knows that it's from this office, they don't know which of the people in that office is the one that wrote the bad checks. So here's what we have and what we're going to do. We have the checks. All the checks were written with black ink. Now, sometimes black ink is black because it's soot or charcoal or just black, and other times black is the result of many different colors being put together, which, when you put colors together, can form black, and I'll show you that a little bit later. The bank has provided the S2S Crime Lab with the checks, and we've had our scientists here actually extract the ink from the checks, and I don't know if you can see it here, but I have, hold it up against my white jacket, but we have a little vial of that black ink. So this is where we're going to try and separate the colors from that black ink and compare it to all the pens from the different employees in the office and see if we can get a match between the pens and the ink. And here's where I need your help. What we're going to do, I'm going to try and do a separation of the colors on the ink, and you have the 11 pens from the 11 employees that are in the office there with the corporate treasurer, and you're going to try and separate the colors from those pens, and hopefully we'll be able to get a match. And if we get a match, all the pens are numbered, we should be able to go back to the FBI, give them the number of that pen, and then they'll be able to go into the office and arrest the individual that's responsible for doing this crime. Okay, everybody set? We're going to work on this together?
Yep.
All right, you guys set for that? Okay. First thing we're going to do now, and you're all in teams? You have partners there that you're working with? Okay. What I want you to do is to take take your filter paper that you have. Okay, what I want you to do is fold that filter paper precisely in half. Okay, you got it with the first fold on that? Okay, then what I want you to do is open it up and then taking and putting those two crease marks next to each other, fold it in half again so we make, in essence, an X with the folds that will go right through the center of the paper. Okay? You guys got that done? All right, now what I want you to do is flatten that out a little bit. Okay? Now, you should have a clear cap. And I'm using a black cap here just to make it easier for you to see. But what I want you to do is to put that cap down, and then I want you to put the paper over the top so that the center of the paper is over the hole of the cap. And then what I want you to do with your pencil is find the center where that X is and just make a little hole. Okay, can you see that? We just have a little hole that goes through the paper. Let me know when you guys have got that done. Everybody got that done? Anybody need more time?
Nah, we good. We're good.
You guys are good? Okay. What I want you to do, we're going to let that sit for a minute, but I want you to take the wedge now, and maybe the other partner can work on this. And what I want you to do is take that wedge, and I want you to fold it in half to make a smaller wedge. And then I want you to fold it in half again to make it an even smaller wedge. And then I'm going to put it on the table here because I got to lay it down to do it. And then I want you to see if you can fold it even one more time so it's almost like a little pointy wedge. Okay? All right, we're going to set that off to the side now. Now let's go back to our filter paper. And what I want you to do is put the cap over the top this time, right over the hole, center it on the hole, and then with your pencil, I want you to draw a circle right around the edge of that cap. Okay, so it looks like that. And again, if it's not perfectly centered, doesn't matter. We just want to have a point of reference where we're going to do something. Now we're actually going to put 4 different pens on each one of these filter papers, okay? So I'll show you how we'll do one, and then you're going to do all 4. But let's say this was your pen, and let's say this had a number 3 on it, okay? So what you'd want to do is you'd want to pick one of those 4 pie-shaped wedges, and at the top of it, write the number. So you can see I've got the number 3 there. Turn it around so you can see it. And then what I'm going to do is write on the circle that we made in that same little pie, I'm just going to put a little teeny dot of ink. You guys see that?
Everybody see it?
So that would be now for pen number 3. When that's done, give that pen to somebody else, take their pen, and then in the next section you'd write that number and put a dot there, and another number and put a dot until we have 4 different pens on the filter paper. Okay? While you're doing that, I'm going to do the same thing with the ink that we got from the checks. Okay, so what I've done is I've taken the ink and I've made 4 different spots, and I've actually made them from very light to very heavy, because I don't know how each of your spots is going to compare, and that way we're going to be able to see what this matches up with in terms of the pens that you have. Okay, so let me know once everybody has all their 4 pens on their paper.
So you said all 4 of them.
You guys got them?
1 minute.
Okay, so what I want you to do now is take that wedge that you made, and from the bottom, I want you to stick the wedge through the hole that you made in the filter paper. So it looks like that. Okay?
Right? How many did you guys get? Got 3? Huh? You know where the other one went? You got 3 though? Put down. What number do you have? Yeah, so put number 9 on. Everybody got them? Everybody got 4 dots? All right. Okay, you got yours? All right. You got 4? Okay. You got 4? Perfect. You got 4? Okay. Don't put it too much. Okay, got 4? All right. Okay. All right. Rich, we got all of our 4 dots on.
Okay, does everybody now have their little wedge stuck through the hole in their filter paper? From the bottom. Again, we're putting it through the bottom, so the point is on the top. Everybody got that?
Got it? Don't push it too far, bro. Yep. There you go. There you go. How about you? Good. How about you? Good. All right. Okay.
We good? Okay. What I want you to do now is I want you to hold the pointy end, and I want you to hold it flat over the top of your cup of water, and then I just want you to drop it in. Okay? And then this is going to take some time while it's doing its thing, but let's talk about what it is that we're doing and why. Hopefully this is going to show us which pen wrote the checks. All right, so the technique that we're using here is a form of chromatography, and it's called paper chromatography. Okay? So what is chromatography? Chromatography is a separation technique whereby a liquid, which is called the mobile phase, flows through and over a solid, which is called the stationary phase, and some compounds, in this case they're colors, like the liquid, so they travel with the liquid, and some colors like the solid, and so they stick to the solid, and over time they separate from each other. Now, what I'm going to do is, well, first off, in this case, the solid is that piece of filter paper that we put the ink or the pen on, and the liquid is water, which you have in those cups. Now, if I can, I'm going to show you why we hope this works, and going to do it with some colored solutions. So over here, I have colored water. I've got blue, I've got red, and I've got green, okay? And what I'm going to do is take a electronic pipette, and I'm going to take out some of these, and I'm going to mix them together. So in this case, I'm going to take out a little bit of the blue color, and I'm going to put that blue color into a test tube. Okay, now I'm going to take some of the red color, and I'm going to put that red color into the same test tube. And finally, I'm going to take some of that green color, and I'm going to put that green color with the red and the blue color. So what we have here is a mixture of red, blue, and green, and when you put those three together, you make black. Now, the reason that paper chromatography works is because the paper likes the water. It sucks the water up. This would be like if you were home and you had a napkin, paper napkin on the table, or a piece of paper towel, and the very corner gets wet, and then you can almost watch the water get sucked up through the whole piece of paper. Well, if you can see over here, I've put the black water into this cup, and now what I'm going to do is put in a piece of filter paper, like the filter paper we just used, and you can see that the water is starting to travel up the paper. Okay, while that's going on, let's take a quick look and see what our filter paper experiments are running. So we can see here with the ink that I've got from the check, we're already starting to get some nice separation. I've got, it looks like, some blue on the outside, and then it's going in toward the center. There's some red, looks like yellow with almost like a black stripe inside of that. So it looks like we're getting separation. I don't know if this is starting to match with anything that anyone has out there, but we'll let this sit for a minute. I'm going to show you right now a classical picture of paper chromatography doing this same thing. So you can see here, this, instead of running the way we're doing, which is called radial chromatography, it's running out from the center out to the edges. This would be where the water is running up the piece of paper. So number one in that slide is the water. Number two is the paper. Number three is black ink. And you can see the water's been traveling up that, and it's separated into green, blue, yellow, and red. And in this case, the red color really likes the water, so it travels the most with the water. And the green color really likes the paper, so that sort of stays behind and sticks to the paper. And then in those number 4 over there, you see all the individual colors by themselves, and the fact that they move to the same distance as they do when they're all together in that black ink. So that's what our classic chromatography looks like. We're hoping to get sort of that same separation here and match up with the pens. And the important part is it's not just the colors, but it's where those colors wind up on that piece of paper. While this sits, what I'd like to do is go in and see Ellen in our main laboratory and see what she's doing today. Ellen. Ellen, are you there?
Hi, guys. Yeah, I'm here. Hi. So in here we're working on a different problem. Instead, you guys are working on a criminology problem. I'm doing a pharmaceutical problem. And we're looking at a different technique, still a chromatography technique like you're using, but in this case, it's one called high performance liquid chromatography, or HPLC. In this case, we're still using a solid phase, and that is inside this column. We have little particles, solid, and we have a liquid phase that we deliver through these channels up here. We have a solvent here, and it's going to go through here, go through our column, and again, we're going to see separation like you're seeing on your paper. Okay? The case I'm looking at today is a pharmaceutical problem, and it has to do with cough medicine. The FDA has come back, Food and Drug Administration, and said that some people are complaining that there may be some contaminants in some cough medicine. Right? So we're going to look at a video that shows us how the separation works on here, and then we're going to talk about what we actually see in our chromatograph here. Okay? So we have our bottle of cold medicine, and we pour that into a little vial, and the vial we can put inside our auto sampler, and that's going to take a little bit and put it onto our column. As you can see coming up on our picture here, we have a separation. We have 3 different compounds, 3 different materials coming through our column, and they're moving at different rates, just like on our paper. And as you see above it, you can see little bits of peaks coming up. And those peaks will show us those different materials and what they are based on when they come out. The first one is an antihistamine. That's for your nose. The next one is a little bit of aspirin, okay, in case you have a headache also with it. And the third one that comes out that the peak is not quite showing up yet is our actual cough medicine, okay? And we can separate those 3, and we know that those are things that are supposed to be in our mixture. What we found instead, I'm showing here, and we'll go up on your screen in a minute, is that we actually have 8 different peaks. Now those peaks are not what we expected to see. So we need to see whether those peaks are just inactive ingredients in our cough medicine, or they are some impurities or contaminants or toxins that we need to figure out what they are to see whether we have what we're supposed to have in there, or whether we need to go back and actually tell them that yes, we have some contaminants in there and they should pull that off the market. Okay? So that's what I need to get back to working on now. So I'll see you guys later, and you guys are going to go back and look at your samples now and finish solving your case for us too, all right? Thanks. Bye.
Wow, Ellen, thanks for that. And as you guys can see in our crime lab, in our forensics lab, we do a wide assortment of different types of testing. In this case, we're doing some testing for the FDA. Again, food and drugs want to make sure that there's no nothing that's been made toxic, or there's no impurities that would get into the medicine or in the food chain. We were doing work here with crimes, and in this case, crime against a corporation. A lot of different things that can be done in forensic science, and we try and do all of that here at the S2S Technology Center. One last thing before we go back and look at our chromatogram, I want to show you something. It's also a little video, but it's a slightly different. It's not as complicated as HPLC, but it's a little more complicated than the paper chromatography that we're doing, and they call this flash chromatography. And what's nice about flash chromatography is you can actually collect the compounds that come off and then go and do other testing on them. So you can see here we've got a liquid, dichloromethane on the left, and turning on the pump and adjusting the flow, and now that liquid is going to go through that glass column that has those particles in it, and again, in this case, it's going to be a color separation. So if you notice out the bottom of that column, it's going into a bunch of test tubes, and we're going to collect what comes out. So the first tube is filled. We've moved it to the second tube, starting to collect more in the second tube. And you can see we've got two colors. We've got a red color and we've got a yellow color, and hopefully we're going to get test tubes with those two colors in it. Okay, we're going to switch, and now we should have a tube that's got the red color in it. So as you can see there, yep, there comes all the red color. And that's been separated from the yellow, which in a second, yep, there's the yellow. And everything else is now out of that column. And again, the nice thing is we can take those and we can do additional tests on the red or the yellow separate from each other, and we'll shut the pump off now. Okay, so let's go back and let's look at our paper and see what we have here. What I want to do is actually take it out of the water, and then I just want to set it. We can pull the, I'm going to pull the wick out of the bottom, and then just set it down on the table. Now, as I say, the important part about this is it's not just the colors, but it's where those colors come out. So as you can see, we've got yellow close to where we put the ink, and then it's into like a little bit of a purple that goes into a red with dark blue and light blue at the very top. Now this is the ink from the check, so whose pen looks similar to this? Set that right there so it's a little bit easier to see. What do we think is the pen that's most similar to what we're seeing here from the ink?
One that's close? No?
I'm actually going to pull up a slide. We had done this a little bit earlier today, so maybe it'll be easier to see off the slide. So that's the slide that we have there. You guys want to yell out a number that you're seeing? 7. It looks like number 7. I've heard. Any other number?
We got 7 over here. She's going to jail.
So, who thinks, if you guys would raise your hand, who thinks it's pen number 7 because you ran 7? Wow, okay, so it looks like we have a lot of confirmation on pen number 7. So what I'm going to do as soon as we get done here, I'm going to place a phone call to the FBI. I'm going to tell them that between your work and my work here that we've determined this is pen number 7. They know the individual that uses pen 7. They didn't want to tell us that. And they're going to go straight to the office now and arrest that individual. And hopefully this is the way we're going to have this crime solved and have it all done just from the work that you've done and the work that we've done here. So what do you guys think of that?
What do you guys think? I love this young lady's comment, right? I said to her, I said, you're going to, based on what you did today, you're sending someone to jail. She goes like this. Science is sending them to jail.
That's right, yeah.
Okay.
That's true, because when you go into a court, so you can ask somebody and ask them questions, and some people can lie, and some people can sort of not tell the whole truth. But if you've got science, if you've got something that's black and white, or in this case, yellow, red, and blue, there's no argument.
So, Rich, you bring up a good point, right? If this whole group of people were doing this experiment, right, and you got number 7, one of you who did number 7 would be asked to come to court and serve as an expert witness. So, as a scientist, it's great to do the experiment. It was the science. It wasn't you that sent the person to jail. However, you're going to be our expert witness today. So I would like you to come up, stand up, swear to tell the truth, the whole truth, nothing but the truth. Yes? Okay. So, why don't you tell us exactly what you did defend the science. Tell us how you did it. You put it on the thing? Come on now, you can do that. What did you do today? Who else wants to take a stab at this? Come on up here. Tell us how you ran it. You're a scientist. Somebody's life depends on this. They're going to jail. You need to explain the science. So you tell me. Wait, whoa. Tell the truth, not the best truth? Yes, you do. Go ahead.
Well, we used, we compared 4 different types of pens,
Okay.
and we compared them to the ink that we found on the check.
Okay.
If some of them were kind of alike, we had to look at them and see which one was closest to the ink, the colors of the ink from the check. And we found that number 7 was the closest one. It had dark blue and light blue at the top. It had red and then yellow, which is just like how the check had. This is called
Yeah.
chromatology, and so we were able to find out that number 7 is the culprit.
There you go. In today's world, right? Everybody talks about it being a global world, right? Sharing of data, sharing of knowledge, sharing of everything. Well, scientists have been global from the day that it was discovered. Okay. So one very important thing, all right, in today's world is you did this experiment. Okay. You compared your results amongst yourself, but you could compare your results amongst anybody. We could have 10 other laboratories doing this because we want to be sure, right? So we confirm the results amongst ourselves. But the most important thing about science is you have to be able to communicate your results. This young man did a fantastic job communicating his results. All right? He didn't do so bad. Okay? So you have to be able to communicate. So English is important. Okay? Computer skills are important. All of the things are important. Okay? You either have to write your results down, you have to write articles, okay, or you have to present your results. Okay? So, even though you like science, you want to be a scientist, okay, you've got to pay attention to the other classes as well, right? So, when this grant comes, does anybody have any questions for Dr. Meyer? None? How does he look? Look good? They say that the camera puts 10 pounds on you. You think he put some weight on? We won't ask that question about else, right? I don't think she'd appreciate that. Okay? So, guys, thank you very much. All right?
Thank you.
Have a good day.
Nice working with you guys today. Take care.